All right, let's look at some problems from this quiz review worksheet over 7.2 A, B, and C. So this is going to cover this method, washer method, and volume of known cross sections. So for number one, it says determine the volume of the solid generated by the region bounded by y is equal to x cubed over 2. That's the cubic function here. Bounded by y equals 4, horizontal line, and x and the y-axis, or x equals 0, in the first quadrant. So we're told where to make our shaded region, and our axis of revolution is going to be about x equals 0. So x equals 0 will be a vertical line. Okay? And if we want to find the volume of a solid that is revolving about this, then we have to decide, are we going to be using this method or washer method? Okay. So notice that this shaded region is right up against this axis of revolution. There's no gap, there's no hole, so we only need to find one radius. So starting on the axis, we draw to the curve, and we see that we're using horizontal radius. So we know this is going to be a right minus left form, and we're using this method because there's no gap, there's no hole. We only need to find one radius. So we start with this radius. We look at the right endpoint. The right endpoint is on the curve y is equal to x cubed over 2. But we have to make an adjustment because if we want to use the right endpoint, we have to get this in terms of x equals. So we can cross multiply. X cubed is equal to 2y. So x is simply equal to the cube root of 2y. So big radius is simply going to be the right curve, which is cube root of y, cube root of 2y, minus, and the left curve, the left graph of this left endpoint will be at x equals 0. So we simply get cube root of 2y minus 0, so that represents big R, big radius. And we need to plug in our bounds as well. So if you look at the graph, you should be able to tell that the lowest y value you see is 0, and the highest y value is just going to be this horizontal line, y equals 4. So our bounds will go from 0 to 4. Our disk method formula is pi big R squared. So we simply plug in our calculator, and we're going to get 9.6 pi cubic units. Okay. Part B, we're still dealing with the same shaded region, but now we're going to be revolving around the line y is equal to 4. So y is equal to 4 is a horizontal line. Again, it is right up against this graph. There's no gap, there's no hole, so we know this will be simply using this method. So starting on the axis, we draw to the curve, and we see that we're using a vertical radius. So we know we're going to be using the formula top minus bottom. Everything will be in terms of x. So we look at the top of the graph, and that is at the equation y equals 4. So 4 is going to be the top graph. The bottom of the radius is hitting the graph x cubed over 2, so we get 4 minus x cubed over 2. We do need to find the bounds because this y equals 4 is a y value which is not going to be what we need for our x value. So if we look at this graph, we're looking for x value, so we're looking for the furthest left, which is 0, and the furthest right, it'll be whatever this x value is. So to do that, we need to set the equation, this curve, equal to y equals 4. When we do that, we get x cubed over 2 is equal to 4, x cubed equals 8, so we get x is equal to 2. So we know our bounds will be from 0 to 2, big radius squared, and we don't want to forget the pi. So pi big R squared, plug in your calculator, you'll get 144 over 7 pi cubic units. Okay. Part C, again, the same shaded region. Now we're going to be revolving around the line y is equal to negative 2. So here's the shaded region. Here's y equals negative 2. And you see that there is a gap, not only a gap, but there's a hole between the axis and the shaded region. And because of that, we know we have to use washer method. So we start on the axis and we draw to the curve or to the line or to the graph that is further away. Okay, so this will be big R. And then we're going to start on the axis again. We're going to draw to the curve that is closer, and that'll be the cubic graph. Okay. Now we drew vertical radius, so we know we're going to be using top minus bottom, and we already knew that we're using washer method because of the 2 radius. So now we need to find the distance for the radius. So big R, we start at the top of the radius, which is at 4. So we say 4 minus, we look at the bottom of this big radius, which is at -2. So 4 minus a -2 is simply 6. Okay. Next, we look at the small radius. So the top of the small radius is hitting the cubic function, x cubed over 2, minus, now we look at the bottom of the small radius, which is on the axis of revolution, which is at -2. So x cubed minus a -2. 2 negatives cancel out, we get x cubed over 2, x cubed over 2 plus 2. Our bounds will stay the same as from part B, because we're talking about the same shaded region. So we're still going to go from 0 to 2. We solved for x before, so we'll use that information again. So our volume is pi big R squared minus little r squared from 0 to 2. And plug this in your calculator, you'll get 360 over 7 pi cubic units. All right, part D, same shaded region. Now we're going to be revolving this shaded region about the vertical line x equals 5. And if you look at the shaded region in relation to the axis of revolution, you're going to see there's a hole. So we know we're going to have to use washer method to account for the hole, which we have to subtract out. So starting on the axis, you're going to draw to the further graph or the line, which is the y-axis. And then we're going to start on the axis. Again, the axis is the center of your graph. You always have to start on the center, in the center, because we're creating radius, and we have to include the center when we're drawing radius. So starting on the axis, we're drawing to the inner curve, the curve that's closer to the axis. And you can tell which one is going to be big R and which one is little r. Your big radius is always going to be longer in length than your little r. So then you start to find big R by locating the endpoint, the right endpoint of your radius, and see where that graph is touching, which is at 5. So we say 5 minus, and the left endpoint is on the 0, so 5 minus 0. Okay. Little r, we are starting at the right endpoint, which is at 5, minus, and again, the adjustment that we did from part A, which is solving in terms of y, so x is cube root of y. So 5 minus, and this curve is represented by cube root of 2y. Okay. Our bounds are from 0 to 4, which we found from part A, the lowest y value to the highest y value. And we plug into washer method formula, which is pi big R squared minus little r quantity squared between the bounds of 0 and 4. Okay. Plug all this in your calculator, hold on to the pi value until the very end, and you're going to get 50.4 pi cubic units.